Module 6, Lesson 4, VMFS Data Stores. After this lesson, you should be able to create a VMFS data store, explain the VMFS locking mechanisms, increase the size of a VMFS data store, and delete a VMFS data store. Using data stores with ESXi hosts. You can use VMFS or vSphere virtual volume data stores when accessing block level storage. VMFS is a virtualized, optimized file system for storing and accessing large files. VMFS data store can have a maximum volume of 64 terabytes. Virtual volumes can use advanced storage services that include replication, encryption, dedupe, and compression on individual virtual disks. Virtual volumes support vSphere features such as vMotion, storage vMotion, snapshots, linked clones, flash read cache, and DRS. You can use RDMs if any of the following conditions are true of your virtual machine. It's taking storage array level snapshots, it's closer to a physical machine, and it has large amounts of data that you do not want to convert into a virtual disk or a VMDK file. Creating and viewing VMFS data stores. This is where you store your virtual machines. This is a data store for storing that. You can use the new data store wizard to create a VMFS data store on any SCSI-based storage devices that the host discovers. This can include Fiber Channel, iSCSI, or local storage devices. VMFS, like it said, is a block level file system. That being said, it's a raw LUN that is presented to your ESXi host, which can be by SCSI or Fiber Channel or iSCSI. So it's a file system that, such as like your computer, if it's Windows, uses NTFS. That's a raw hard disk. The Windows formats it as NTFS. ESXi will see a hard drive and you can format it as VMFS. You can browse the data store contents. When you click on the data store view, it'll show you the data stores, and you can right click on it or click on it and go over to the files tab, and you can browse it and see what files are actually on that data store. Managing overcommitted data stores. A data store is overcommitted when the total provision space of thin provision disk is greater than the size of the data store. So let's say I have a 1 terabyte data store and I have a virtual machine on there that's thin provision, but I give the VMDK 2 terabytes. Now that's overcommitted because that machine has the capability to consume up to 2 terabytes. Even though it might not, it still has the capability, because we've told that VM that, hey, we've got 2 terabytes of space available to you, but we really don't. You need to actively monitor your data store capability. There's alarms that will assist in this. You can use reporting to view your space usage. It'll actually tell you how much space is being used. So if we had that one virtual machine on its own data store of 1 terabyte, and we start seeing it get up to about 1.7, 1.8 of actual data where the disk has been inflated to use that much because it has that much data on it, we might want to look at increasing the size of that data store or moving that machine to another data store that has more capacity. In that scenario, we need to increase the size of the data store, or we choose to do that and not move it to another one. We need to then, we will give either, let's say it's on a SAN, we would, on that LUN, either add another disk or increase that size, however we do it on the array, to where there's more size there. So instead of it being 1 terabyte, it's 2 terabyte. So now we see that. We're presenting that LUN to VMware as a 2 terabyte LUN on our physical array. We then need to, on the ESXi host, perform a rescan so it can see the most current storage and record the unique identifier. Then we increase the data store capacity or size to use more of that LUN. like I said, we can add an extent or we can expand the data store within its extent. However, the storages you're presenting to the SXI host, however you can increase it at the hardware level, then you would rescan and it shows that you have X amount available, and then we use the vSphere to increase the size of that partition basically. You can delete or unmount a VMFS data store. When you unmount a data store, the data remains intact, but the host cannot see the data store. It's become unmounted. It's not able to see it. It don't have a way to access it. But the data's still there. We can always mount it again. When we delete it, we're destroying that partition, deleting that VMFS, so that the files on it are gone and the files are permanently removed. We can use multipathing with VMFS to get to our array. And again, this depends on your array. You need to look at your manufacturer for that array on how it does it. In this example, we have 2 storage processors, and this may be over IP, maybe over fiber channel. And we have multiple ways to get to each one, and notice they all go back to a HBA on the ESXi host. And third-party vendors, again, like I said, you need to see whatever array you're putting in, the manufacturer, on what they recommend, because they can offer, vSphere offers native path selection, load balancing, and failover. Third-party vendors can have their own software that you install on the ESXi host. And this will enable the host to properly interact with the storage array. Then they can be storage plugins or whatever. To configure storage load balancing, with select policies we can do round robin. This is a multipathing policy that performs load balancing across paths, and we can ask for scalability. For availability, we can use MRU, which is the most recently used, and we can use fixed. You should now be able to create a VMFS data store, explain VMFS locking mechanisms, increase the size of a VMFS data store, and delete a VMFS data store.